Hello everybody, and welcome to exercise 2 on page 33 of the workbook. And let's take a minute just to read this problem here. So the displacement of a car from its starting point after t hours is given by d equals f of t miles, and we are given a graph of the function over here to the right. Let's maybe start by reminding ourselves what units we're talking about here. So on the horizontal axis down here, we've got time. They're telling us that's being measured in hours. And then up on the vertical axis, we've got distance, which is being measured in miles. Okay, and the graph is kind of what we've got to work with to answer the questions they're asking us here. So let's start with part A. So they'd like us to estimate the time intervals on which the car has positive acceleration and to explain how we identified those. Okay, so how do we use the graph to figure out where the car is accelerating? Okay, well, let's first maybe remind ourselves what acceleration really is. It has to do with the rate of change. You might remember, and we talked about this before, that if you take the derivative of the first derivative of a position function, you're talking about velocity. And acceleration is about the rate at which that velocity changes. It's the second derivative. So if we rephrase what they're asking us in part A, it's like asking us, where is the second derivative of this function that we're given positive? That would be a positive acceleration. Okay, now there are different ways that you could do this. I'm going to use kind of a graphical approach in this case. So if we want to find positive acceleration, we want to look at where our graph is concave up. And you might remember we made the observation that the shape of a concave up function is like a right side up ball. So can we find the portions of our graph that are shaped like a right side up ball? Okay, I'm going to start at the beginning here. And notice that the first part of the graph doesn't work because that's more shaped like a downward facing ball. But then we reach a point where it starts sort of bending in the other direction, shaped more upward. And the question is, where does it start bending upwards? Okay, if I had to pick a number, I'd say maybe in the vicinity of 2. Okay, that's just a rough estimate. You might disagree with that. But it looks to me like from 2, this part of the graph that I'm tracing out kind of has a ball upward shape. And the question is, how long does it have that shape? Okay, to me it looks like that ball upward shape stops at about t equals 6. And again, that's just a very rough estimate. So on that interval of time between 2 and 6 hours, our function appears to be concave up, which means that the car is going to have positive acceleration. All right, let's write that down. So we'll say on the interval 2 less than t less than 6 hours, because the graph of f is shaped like a right side up ball. Okay, and that's the shape that's typical of a concave up function. Okay, so what about part B then? So this just asks kind of the reverse question, where does the car have negative acceleration? Well, here we'd just be looking for where our function is concave down, and that's going to happen on the other intervals, okay? Places where the graph looks like it has sort of a ball down shape. Notice that from 0 to 2, we kind of look like the left-hand side of an upside down ball, and then from 6 to 8, sort of the same deal. Okay, so from 0 to 2 hours and 6 to 8 hours, those appear to be intervals where we're getting concave down shape and therefore negative acceleration. Okay, so on the intervals 0 to 2, and whoops, not 2 again, 6. 6 less than t less than 8 hours. Okay, because the graph of f is concave down on these intervals. Okay, or maybe it would have been better to say appears to be concave down. We're really just estimating. So again, you might have done this problem and gotten different numbers than I did. That's okay. We're just estimating as best as we can. All right, and then finally, part C asks us, during the first 5 hours of its journey, could we estimate when the car has its minimum velocity? Okay, so first, remember, they're asking us to just look at the part of the graph between 0 and 5, so kind of the part of the graph to the left of that dotted line that I just drew. Okay, and velocity, remember, is about the first derivative, okay, which graphically would just be the slope. So it's like asking you, if you look just between 0 and 5 hours, where do you think the minimum slope is happening? Okay, and to me it looks like it's kind of right in the middle, that place where the concavity changes. If I drew a tangent line there, I think that's going to have the least slope out of all of those points in the first 5 hours. So my estimate would be at about t equals 2 hours. Okay, and we'll just make a comment that this is where the slope is the smallest on this interval. Okay, we could maybe say between. Okay, and I think that's the end of this problem.